Next kita akan masuk pada chapter yang kelima. It's about energy storage, and in energy storage we will learn a little bit about a few components that concerning this energy storage. First of all is a capacitor, and then the second part it will be the inductor. Okay. So at the end of the class, students should be able to identify the type of energy storage device and able to explain the working principle of capacitor and able to calculate the value based on the connectivity. Okay, so we will skim through a little bit today before doing a lot more calculation for tomorrow. So what is the energy storage element? Obviously, we can say that it's a stuff or components that are able to store energy. How to store energy? So how to store energy? So these are there is a few components like a battery. So battery is the device that able to store energy. And then pendulums, a fuel tank, right? Your fuel tank inside your motorcycle or car is a way how to store the energy, because your engine will convert it into the using the hydrocarbon process. You convert it into the heat and then to energy. And we can say in terms of electronic, we have capacitor and inductor as one of energy. Okay, so as you know, they are similar between capacitor and battery. The only difference is the battery able to hold or store your energy in a more longer period of time. Okay, so you can store the energy up to 1 year, 2 years or more inside a single cell or batteries. While in capacitor, it can store energy, but it cannot retain it, or it cannot hold it when the circuit is off. Typically, the capacitor cannot hold that long. A small capacitor can hold the energy inside and will be diminished perhaps by 1 month. For example, there is application inside your device, right? So, for example, you have, as you can look at your Astro punya decoder, right? So you start the time, waktu dia, and you have also, if you have a small radio, digital radio, and you can store the clock or the date, or you store the memory, or store the value of channel that you like to hear every day inside your radio. But when you turn off the radio, pull the plug off, right? The memory will remain to a certain level actually. When you plug in back, and then your radio, for example, I think I can open okay, let's take a look at this very simple radios, right? So here you have a channel, the display here, you can see if you have at home or inside your room, you can store the value of clock, a value of channel memory, and so on. But if you plug it off, this radio, you cabut dia punya plug daripada dinding ataupun from your plug, everything is turned off. You tak pasang bateri pun, tapi everything is turned off. And then when you plug in back, you dapati setiap daripada memory yang ada di dalam radio tersebut masih kekal. All the memories that you have set, channel 1, channel 2, Hits FM, Fly FM, whatever FM that you are listening to, it's still there and it's remain there even though it's almost 1 week you have not plugged in or turned on the radios. Why? Because in this case, even though you tak put apa-apa battery inside, there is no battery inside. But actually, we engineers put certain capacitor value that can keep the memory of this panel for at least 1 month. So in Panasonic, last time I need to test it that these memories should be able to withstand up to 1 month. Selama 1 bulan. Maksudnya saya dah set tu, and then I letak dalam chamber for 1 month, and then selepas 1 bulan saya keluarkan, dan saya kena check balik everything, the memory should be there dan tak hilang. That's how we ensure the quality of the products lah in Panasonic. So I did that 1 month of checking. Maksudnya dah on kan the set, and then you off and you left it there. The next, after 1 month, you turn on balik and make the report whether everything, the circuitry should be able to hold the memory or not. And all these features are not using with the help of batteries, but only by a capacitor. So a capacitor should be able to hold at a very short period, comparatively, when we compare to the battery, it can hold the charge for the shorter period of time. So these are several types of capacitor that you can find, from the big one to the smallest one. And this is what we call as a radial capacitance. So radials means it's put on the top of PCB in the radial form, radially. So they are the axial and radial components. So axial capacitor, I lupa nak cari picture for you. So here you can see the example of axial capacitor. The structure is slightly different, right? Itu letak dalam kita punya slide. So you can see the difference in terms of structure. For axial, it will have the pin or the leg at the same side, while for the radial, it has something like from the end to end of pin. So this is a radial, and this is the axial, and this is the radial capacitor. It's just how you put on the PCB later on. Okay, so perhaps I can share about kat mana biasanya komponen-komponen ni, kan? Where we should add all these components. So you can see here, this is the example of a PCBs or electronic circuit, printed circuit board with all the components inside. So here you have, this is a diode. You nampak tak saya punya mouse? So this is a diode, and this diode is in the axial form. So it will put one leg here and the other leg over there. This is wrong way, not necessarily wrong way lah, because of the they need the value of This is the axial radial capacitor, but they put it in the axial way, kind of unprofessional way to do that, but it still do the jobs. This is the example of SMT, or surface mounted technology. This is also a capacitor or resistor. Kalau the level C mana dia capacitor, C93 mana capacitor 93. So all these are capacitor, you see. Kalau resistor dia akan lebih pipih lagi. So this is very small, and this is what we call as a axial SMT component, SMT. So here you have a capacitor in very small form, especially in which they are typically using inside your handphones. So this is the surface mounting technology, SMT. So the component is smaller. So your computer, most of your computers using this. Bigger electronic device or higher power electronic device will more likely use this kind of components. But PC, smartphones, they are very low power device, and they are able to scale down the energy required to run that. So similar goes to the component. We can use a very low voltage value of components. So it impacts to you then. This is example, not the real one, but it can do the field. This is a capacitor in SMT technology, surface mounting technology. This is also a capacitor in which the value will much more bigger compared to this kind of capacitor. So this is SMD capacitor. This is the radial SMD. So nampak, kalau radial tu bermaksud dia punya kedudukan komponen tu akan berdiri daripada PCB board itu. If it's an axial component, maksudnya dia adalah baring macam ni. So kalau radial, so as you wish, macam right now you are wishing that you have a smartphone yang paling nipis lah, apalah. That's why they need to use all the radial or SMT punya technology in order to get the thin smartphone that you have. Kalau you perasan kebanyakan smartphone sekarang tebal kat area mana? Area camera kan. So the camera part has lens in between. Dia claim ada 7 ke 8 keping lens in between a camera. So dia tak boleh nipiskan lagi handphone tu. They can nipiskan at the other parts, but in order to get a very good picture, still you need to play around with the lens, and the lens cannot compromise in terms of thickness. That's why sekarang iPhone 7, starting daripada iPhone 7 sampai iPhone 11 semua apa, nampak lens dia terjujur keluar daripada surface, because they are pursuing for the better quality of picture by sacrificing the thickness. So your phone nampak masih need to be a certain level of thickness because of the lens. So lens punya fizik you cannot play around right now. Jadi physically dia kena ada ketebalan tersebut. Jadi tak boleh nak kacau, tak boleh di modified melalui teknik elektronik. Jadi paksalah handphone tu tebal sikit dekat area camera. Okay. So I hope you have a better clear picture what is capacitor is, macam mana form dia, bentuk dia. Okay. So nanti I will put more value or more pictures on how it looks like. So this is the symbol. You can see the symbol. You have a standard symbol like this, a 2 parallel plate, parallel bar with the 2 connection. And then this is the old symbol, but it is already absolute. We don't use this anymore. And then we have also electrolytic capacitor symbol like this with respect to the polarity. Some capacitor has polarity and some don't have. So you need to check on it. Okay, if it's like a tantalum capacitor, it has no polarity. So dia tak ada tulis mana positif negatif. So typically a capacitor yang ada polarity dia akan always shows di mana here you can see the marking negativity, that means this kaki adalah negatif. Okay. So dekat body dia ada clearly marking. So macam diode pun ada polarity juga. So dia akan marking. Clearly marking and you to see. And you can tak boleh pasang balik. Okay. So non-polarity, if non-polarity capacitor, ada masalah. This is example of non-polarity. You can put it in either way. Tak ada problem. Okay. So the origin of capacitor actually is store static electricity charge between two electrodes. Okay. So it's invented at the more or less about the same time between these two persons. The German scientist Ewald Georg von Kleist had invented it, and also the same concept has been done by Peter van Musschenbroek of Leiden in Netherlands. So these are the two persons who are introduced the capacitance or capacitor concept. Okay. So what is inside? Actually, you have inside the capacitor you have negative charge connection and then positive charge connection, the anode and cathode, and then you have two sheet metal here, metal plate. One will be connected to this side. So one sheet metal plate will connect it to negative charge connection, and the other one is connected to positive charge connection. Then why dia dalam bentuk bergulung begini? What's the reason? The reason because any comment, any input, boleh type tak? Kenapa dia bergulung macam ni? Most of the capacitor. So most of the capacitor in this form or in the radial form because they would like to achieve the bigger area. So basically, capacitor is built by a two conductive plate or metal plate and then separated by a dielectric material like air also dielectric material, and then it is separated by this dielectric material. So this gap will give you, and this area of A will give you the value of will determine the value of capacitance, in which how much charge that you can cap inside. Okay. So they are not touching each other, otherwise it's considered as a short circuit. And they hold the capacitor, its whole charge between these two plates inside this cylinder form. So actually the basic structure is we have two conductive plates here, and then you have a dielectric material or dielectric area that's separated between these two. So kenapa dia pakai dielectric? Because we don't want any short circuit between between plate A and plate B, between positive plate and negative plate. So when it is not short circuit, then it will the charge will berkumpul kat sini lah, at this plate and also this plate. So these are the basic structure. You have two conductive plates and you have a dielectric material that will separated between these two plates. So how we measure it? The unit is farad, what we call as a farad. F, the short form as F. So it's depend on the structure of the capacitor, in which C is equal epsilon of permittivity value of the D times D. D is the gap, how big you put the, how far the between plate A and plate B, and then the A is the area value. So epsilon dot times D divided by A. So that's why you would like to have a bigger A area in order to get a higher capacitance value. Okay. So how it's work? And let's doing it by a story. So we have a battery, right, where you have positive charge at one side and negative charge at the other side, and you have a uncharged state of capacitor. When you have in uncharged state, that's mean it's like a neutral, which means you have a equal value of positive and equal value of negative electron and photon inside the one for each side. So bila value dia adalah equal, maka kita boleh katakan dia sebagai satu kapasitor yang stable ataupun yang uncharged situation. So when you put a charge on it, or when you close it off ataupun close the circuit off, hidupkan circuit tu, the electron will start moving. So electron from battery are being pushed to the negative plate of the capacitor because it will be attracted by the positive part. And then the excess electron and negative plate will create an electric field across the electric. Sekarang dah majority dia adalah negatif di bawah ni. So dengan value positif di atas ini, you will have a great electric field. So dia tak balance lagi, nampak. So here you have positive, here you have negative, and then the positive will moving to the positive plate, and the negative will moving to the back to the transferring of the charge. So excess electron and negative plate will create an electric field across the dielectric, which in turn push the electron there away from the plate. Okay. So here you have create a potential of differential potential at C. One VC is equal to V, then the potential is the same, thus no more current flow. So apabila dia dah equivalent, this VC and this V supply and VC is equivalent, then there is no current, current takkan ada jalan, tak jalan lagi. Dan proses ni berlaku sangat pantas. Okay. This process is happen really fast, which I mean from here to here, very fast, less than 1 second. Less than 1 second, you can have a capacitor has the same value of the voltage source. Tak percaya, kita boleh pergi lab cuba. You can buy a battery, you can buy a capacitor, you put it positive and negative, straight away, when you release that, then you measure at the capacitor, you will get the voltage close to the voltage of supply tadi. Kalau battery itu 1.5 volt, you akan dapat 1.5 volt. Okay. So this create potential difference at capacitor, and once VC is equal to V, then the potential is same, so no more current will flow. So, in summary, the capacitor allows current to flow for a brief moment before it acts like an open switch, in which no more current flow. And when this happens, the capacitor is said to be fully charged, and the stored energy is in the form of electric field. So dalam capacitor you akan ada sentiasa electric field. tersimpan. Itulah energi yang tersimpan, yang ini itulah kaedah bagaimana kapasitor menyimpan energi di dalam DVD. Okay.